In this tutorial, we're going to look into the binary system and how to convert from binary to decimal and vice versa. Now, the reason behind that is that some of the exercises, in fact, I think it will be 2 exercises, will use that concept, meaning that we're going to solve how to convert from binary to decimal and vice versa in BashScript. Now, mind you that in computer systems, the computer does not understand decimal values or even floats, so it converts everything into binaries, into bits, such as zeros and ones. So at first, let's say you're gonna need to code a certain number of values. So the formula is 2 to power n, or number of bits, 2 because the base is 2. The bit can only be 0 or 1. So if you have 0 or 1, how many bits do you need to get or to code 5 values or 6 values? So it is 2 to power n equal the number of combinations, all the combinations possible with repetition. So if you need, let's say, to code 16 values, you need 4 bits because 2 to power 4 equal 16. I will show you what do we mean by that. So 2 to power 3, let's say you have 3 bits, you can get 8 values. 8 values being from 0 all the way to 7. So to the right, as you see over here, what we have is sequence of bits. In order to get all the possible combinations, at first you start with 3 zeros. Then you start adding 1 to the right. Now, mind you that here, for example, at the second position, 1 plus 1, you actually add them by using the XOR. XOR meaning 1 plus 1 is equal to 0, and you have a return of 1 which will sit to the left, right over the left position. Okay, so 1 plus 1 equals 0, and you have 1 inserted over here. Then 1 plus 0 over here, you get 0, 1, 1. Then you add another 1. So 1 plus 1 equals 0, and we have the return, which is 1, is added to this one over here. Okay, to the left. So 1 plus 1 equals 0. Then you have 1 over 1 also over here, plus 1 equal 0, and you get another return, and it sits on the leftmost position. This is how you get all the values possible. Now, what are the decimal values of these binary sequences? So for instance, you have 0, 0, 0 is equal to 0, 0, 0, 1 is equal to 1. Why? Because we have what is called the weight that is sitting on these positions from right to left. The lowest weight is always the rightmost position. So the lowest weight is here, which is 2 to power 0, which has the value of 1. Then 2 to power 1 is 2, 2 to power 2 is 4. So let's say we need to get the value of 0, 1, 1 in decimal. You simply add up these decimal values that are sitting over the ones, and you ignore the zeros. So here, this one has the value of 2 to power 0 or 1 in decimal, plus 2, a value of 2. So 2 plus 1 gives you 3. All right? So at the bottom, what you have is 7. Why it is 7? Because you have 3 ones. So you add up all these values, all the weights above, which is 4 plus 2 plus 1, 7. 4 is 2 to power 2, gives us 4. 2 to power 1, 2. 2 to power 0, 1. 4 plus 2 plus 1 equal 7. Another example, so you have here, for instance, this bit sequence 0, 1, 1, 0, 1, 1, 0, 1. So you go up and you see the value of the weights above each bit, and you only consider, as usual, the bits that are lit up, that are turned on, which are ones, namely. So the decimal value over here is 64 plus 32 plus 8 plus 4 plus 1, and it gives us 109. Another example is 001, 01, 001. So what are the values or the weights sitting above these ones? You have 32 plus 8 plus 1, it gives us 41. So 41 is the decimal value of this binary sequence. Also over here you have 0, 1, 1, 0, 1, 0, 1. You simply add 64 plus 32 plus 16 plus 4 plus 1 and you get 117. This is the decimal value of this binary word. Down below you have 128 plus 8 plus 4 and it gives us 141. Also another example, you have 0, 1, 0, 1, 0, 0, 1, 1. Okay, I add 64 plus 16 plus 2 plus 1 and it gives us 83. 0, 0, 1, 1, 0, 1, 0, 1. I add 32 plus 16 plus 4 plus 1. It gives us 53. So how do we convert back from decimal to binary? How do we go in the reverse process? So over here we have 134. At first I look at the different weights. So 134 is basically greater than 128, right? So I can subtract 128 from 134. Immediately, since 134 is greater than 128, I place 1 over here. Then I do the math. 134 minus 128, you get 6. Now, is 6 greater than 64? No. 6 is less than all the values except 4. So 4 is the only value that I can take out from 6. So all these other values before the number 4 should be set to 0. And then when we get to 4, we insert 1 and then we do the math because 6 is greater than or equal to 4. 6 minus 4 equal to, so okay, it works, right? So I have this one over here. Then the outcome is 2. 2 I can deduct from 2, meaning I can do 2 minus 2, which gives us 0, of course, and you insert 1 over here. Now 0, I can no longer deduct from it 1 because it's less than 1. So you insert 0 at the rightmost position. Another example. So you have 110. How to convert 110 to binary code? 110 is greater than or equal to 128? No, it is less. You see, it's incorrect. So I immediately leave this position at 0, right? After that, 110 is greater than or equal to 64. It is greater than 64. So immediately you flip this 0 to 1 and then I subtract 64 out of 110, right? So 110 minus 64 equal 46. I have flipped the 1. For 46, is it greater than 32? Yes, it is greater than or equal to 32. So I can also insert 1 underneath 32, right? 46 minus 32 gives us 14, and you flip the 1. You can do it before running the math over it. Now, as for the number 14, is it greater than or equal to 16? No, that's incorrect. So we cannot do that over 16. I leave it at 0. But 14 is greater than or equal to 8. So I need to flip the bit under 8 to 1. And then I run 14 minus 8, which gives us 6. So I flipped the bit here from 0 to 1. We've gotten 6. Now 6 is greater than or equal to 4. Okay, so this is correct. So I can do 6 minus 4, and of course you need to flip the 0 to 1. 6 minus 4 gives you 2. I have flipped the bit from 0 to 1. And finally, I can do 2 minus 2, because 2 is greater than or equal to number 2. 2, so 2 minus 2 is equal to 0, and that's the end of it. So the binary code of number 110 is 011011110, and this is how you do it.